had the opportunity to work with MBTA, as Peter mentioned, and the city of Quincy. So we currently have a preemption system deployed in the city of Quincy. And what we've been able to do is kind of take this to the next level with their transit and talk about their transit priorities. So actually providing priority, providing green lights for the buses so that we can make those routes flow more smoothly, encourage more folks to ride the buses. And the really cool thing about this project is we're doing this with virtual devices. So I'll let Peter talk about the virtual aspect of it, but we can use the same concepts just with different rules set up on how it would trigger things, but to provide priority. And then we've got a virtual application, so we don't actually have a piece of hardware. Where's our piece of hardware in the buses?
So yeah, that's a great thing. And what we're doing is, so generally speaking, the normal way that we do emergency vehicle priority is we use the same unit in the bus system because that's the best way of doing it. You're using 900 megahertz radio, cellular radio, that is by far the best way of doing it. Also, the latency and all the rest is the lowest. It's the most robust way of doing it. But when you've got MBTA that's got over 1,000 buses running through, they came to us and said, listen, we can't install any equipment on there, but we have a live feed that sends all of our bus information to Google. Okay, and that's how Google Maps grabs all the information, where the buses are, what their schedules are, and so on and so forth. So what we did was we've integrated to that feed that we can track where their buses are, what routes they're on, and we can actually provide bus priority based on that information coming back. So we're doing that, and we wouldn't do the same thing with emergency vehicles just because of the safety aspects, because if the feed gets cut for some reason, their server goes down, well, then you don't have priority or preemption. So on emergency side, it's a different story. On a bus priority side, if a bus stops getting a green light, yes, it delays the buses, but it's not a life critical situation. So this is why we've implemented the bus priority using what Emily said, which is virtual buses. So as the bus drives along, he gets connected, and we've now created what's called an API, an application programming interface, into MBTA's live feed that we can track the buses. And we've actually started providing priority to buses in the city of Quincy, and we're going to start enabling it now in Cambridge as well. So, it's a great way of doing bus priority without actually having to deploy anything in the buses. Now, you do need equipment in the cabinet because you need to interface to the cabinet equipment and pull the priority request and set up everything in the cabinet. But it's a great way of also using some of the funding that's available from MBTA to get equipment into your cabinets for remote communication. You also get remote front panel available, so you guys can program your controllers remotely. And hopefully you can grab some money from another agency, which is more important, where you can get all this equipment equipped into your intersections. The important thing is when you're doing transit signal priority, you're reducing the fuel. It's about 19% reduction in fuel, and it's reduced travel times. Now this travel times is, we actually look at it per intersection, that you're saving the bus between, it's sometimes, 30 to 40 seconds per signal, because we send the signal over the cellular network way in advance. So you can keep all of your traffic controllers in coordination because we send it a full cycle in advance. Huge savings, and also not a big effect to traffic. Now, there's a couple of different ways of doing priority. We do it, you can either so MBTA gives buses priority all the time. They prioritizing the buses because they see it as, and they're right in saying that it doesn't actually have a massive effect on on the traffic if you do it correctly. You can do bus priority, conditional-based bus priority, which is another form of doing it. So only if the buses are running late, or if there's a number of passengers on the bus. That's what they're doing here in Cobb County with us. Or there's also headway-based priority, which is keeping the buses 10 minutes apart from each other. And that's another way of, you know, it all depends on what the structure is that the bus company is trying to achieve. But the great thing with this is, you know, you can deploy the equipment, you can get bus priority without having to actually deploy, you know, a huge 1,000 units onto the buses if they are already providing information to Google. So, you know, this is why you've got to have the conversations with the transit agency to see what works best. You know, if you've got a small transit agency, I wouldn't go and, you know, try to do the integration. I would just put a couple of these units on. It's a lot cheaper and less expensive than doing integration. But when you've got 1,000 units like MBTA that goes through roughly 90 cities, this allows us to actually get connected and get bus priority in all 90 cities very quickly and easy.